Okay, so hello everyone again. So this is the episode 2, which is continue from the episode 1, where we already have the problems, the exercise in episode 1. So in this episode, we are going to provide you the solution of the problem in episode 1. So the first question of the problem is that prove that the triangle OAM is similar to triangle OBN. So in order to prove that the two triangle is similar, we need to look for the corresponding angle. Is there any corresponding angle are equal, or is there any corresponding side are in proportional? But if you look at the corresponding side, we have only one corresponding side, which is AM and BN. So we cannot find the corresponding. We cannot prove that the two corresponding sides are in proportional. So it means that we cannot prove by the condition of SSS or SAS. So now we can look for the condition whether the corresponding angle are equal or not. So since the two triangle have, the first one is that you may see that the angle O here. Angle O here is the angle of triangle OAM, and it also the angle of triangle OBN. So when the angle O here is the angle of both triangle, we can say that angle O here is the common angle, which means that it's the angle of both triangle. So this is now we can find one corresponding angle are equal, which means that angle O is a common angle, so that it's the same angle. And the second one you may find that, as you may know, that AM and BM is the two pole. It's the vertical pole, so that this pole are in parallel, so that when the two pole here is parallel, so that angle A here and angle B here is called the corresponding angle. So when the two angle here is the corresponding angle, which means that the two angle here are equal. So now we can find that in both triangle have two corresponding angle are equal, which mean that angle O is a common angle and angle A and B are the corresponding angles, so that we can prove that these two triangle is similar by the condition of AA. So for the second question, um, find the length of OM here. From the question A, sorry, this should be question B, not A. This should be question B. From question A, you already know that the triangle OAM and OBN are similar, right? So consequently, when the two triangles are similar, it means that all the corresponding sides are in proportional. So where is the corresponding side? As we want to find the length of OM, so we need to find where is the corresponding side of OM. The corresponding side of OM is ON, and the corresponding side of AM is BN, and the corresponding side of OA is OB. However, we don't need to give all the three corresponding sides are in proportional, because some of the corresponding side we don't know it. Like for example, OA and OB, we don't know the length of OB or OA or OB, so it's not necessary to provide that. So we just look for the corresponding side that related to our question, what we want to find, and the corresponding side that is given the length, so that we can find the corresponding side where we want to find it. For example, now OM is the side that we want to find, and the corresponding side of OM is ON here, and the corresponding side is the other corresponding side is AM, which is given as 1 meter, and BN with 3 meter. So this length is given so that we can find OM by using this ratio OM over BN. So in here, I can conclude that OM over ON equal AM over BN equal 1/3, because AM is 1 and BN is 3, so it's 1/3. However, I can label OM here equal as X so that it might be easy for you to solve the equation. It's according to you whether you want to label it or not. But however, I just like to label it as X so that it might be easy for you to understand. So if I label OM as X, so OM here I can replace by X. And ON here, you may see that ON is obtained from OM plus MN. OM is 8 and MN is 6, so 8 plus 6 is the distance from O to M. So ON here I can replace by 8 plus 6 and equal 1/3 here. So in proportions, in proportion, when you see that the two fraction is equal, so mean that the outer product is equal to the inner product. So where is the outer? The outer is 8 and 3 is called the outer, and the inner product is 8 plus 6 and 1. So the outer product is 3x, and the inner product is 8 plus 6 times 1, so it's still 8 plus 6. So the inner product equal to the outer product, which means that 3x is equal to 8 plus 6. So that you can solve this equation in order to find the values of x, where the values of x is 3 here, as I think you know how to solve this equation. So now we can find that the distance from O to M, or we can say the length of OM, is 3 meter. Okay, so move to the next question, which is question 3. Sorry, I still put A. That was my mistake. Find the height of the building. So where is the height of the building? So the pink color here is represent of the building. So the height of the building is the distance from P to T, or the length from T to P. So how do we find the length of TP? Yeah, in order to find the length of TPs, I think there are another method to find the distance from T to P, but since we already proved that the triangle here is similar, so you need to compare the triangle OAM. Or actually, it's not just only OAM, but you can compare triangle OBN is also fine, and triangle OTP. OTP. Using the same method as question A, you can compare that the two triangles is similar, which means that the triangle OAM is similar to triangle OTP. OAM is similar to triangle OTP. So when the two triangles are similar, then we will find that the corresponding sides are in proportion, such as OM here, over the corresponding side of OM will be OP, is equal to AM over TP. AM and TP is also called the corresponding side. So as I stated earlier, we can find TP by multiplying OP and AM, OP and AM divided by OM. So we already know the length of AM, right? AM is 1, and OP, how about OP? OP here we can add together, like OM is 3, MN is 6, and NP is 80. So if we add together to find OP, it's will equal to 89. So OP is 89, AM is 1, and divide by OM. OM here is 3. Yeah. So you can see